Okay, so these are the rules that we are going to use for performing rotations. So when a point AB is rotated counterclockwise about the origin, that's important that it says counterclockwise. We're going opposite the way that a clock normally goes. So let's check out for a 90-degree rotation. For a 90-degree rotation, our coordinate rule goes from AB to opposite BA. For example, point A is at 3, 2. Our new point, A prime, will be opposite B, which is -2, and A, which is at 3. So let's check out where A originally was. And now let's graph A prime, -2 up 3. So we can see that point A rotated counterclockwise about the origin. Our coordinate rules for a 180-degree rotation goes from AB to opposite A, opposite B. For example, point B is originally 2, 1. So each position, A and B, will now become their opposite sign, which will be B prime of -2, -1. Let's see what that looks like. Point B is originally at right 2, up 1, and B prime is left 2, down 1. So point B rotated 180 degrees about the origin. And for the last 270-degree rotation, AB now goes to B opposite A. For example, point C is 2, 3, and will now rotate to 3, which stays the same, and opposite A, which was 2 and now becomes -2. So let's take a look at what that looks like. Over 2, up 3, and now rotates to over 3, down 2. So point C rotated 270 degrees counterclockwise about the origin. Let's take a look at all of these rotations separately. So point A starts in quadrant 1 and moves to quadrant 2. That is our 90-degree rotation about the origin. Point B, also starting in quadrant 1, now moves to quadrant 3. So that rotated 180 degrees, which is a straight line. And point C, starting in quadrant 1.
That's a tricky one, isn't it, Ms. D?
That's a hard one to say.
Quadrant 1.
Quadrant 1 rotates all the way around, almost full circle, to quadrant 4. Just to give you a visual of how the degree of the rotation determines where your point, shape, or segment will end up.
Alright, so let's put these wonderful rules into use. We have to graph the quadrilateral. Apparently I have a typo, so it should say quadrilateral. KLMN, and we have to rotate it about 270 degrees counterclockwise about the origin. So I like writing down the coordinates separately, so here we go. And I'll speed up the process for us because I just like to have them off the page. Beautiful. So then I'm going to graph each coordinate, K, L, M, and then N. Okay, connecting all my vertices together. Now let's apply the rule where we have to rotate it 270 degrees counterclockwise. So if our coordinate has the AB as our actual coordinates, the new prime versions will not only switch positions, but the x coordinate will be the opposite. So then K prime will be 2, but -3. You see that? We have L prime, it'll be 2, -4. And then for M prime, we have -3, -4. And then N prime to be -1, -2. Okay, so again, we just switch the positions of the x and y coordinate, and then we do the opposite, or we take the opposite of the original x coordinate, and that is the new y coordinate. Okay, so then let's graph all these vertices. K prime, L prime, N prime, and N prime. And connect all the vertices together, and then there you go. So if you look at the original figure, we've rotated it 270 degrees counterclockwise. So that's why you see the n prime kind of the highest point and the m prime's all the way to the left. It's just completely the figure rotated all the way 270 degrees. Alright, well, we would like you to try these on your own, and the more you know, guys, the better you will be.
Thanks for joining, guys.
Yep. Thank you.